Hi, welcome back to Moose and Chemistry. This is Boyles Gas Law Lesson number 7. So what is Boyles Law? Boyles Law is a pressure-volume relationship, and is written as P1 V1 equals P2 V2. What does this mean? Well, if you look at a graph here, and you put volume here, and you put pressure here, as the pressure increases, the volume's going to decrease. Just like that. Because gas is compressible. And we call this an inverse relationship. So let's look at our problem. Skunks envious of a human's cave decided to use Boyle's Law as a means to disperse their chemical gas weapon in order to grab it for themselves. They noted the pressure of the stored C4H10S stored in their bodies was at a pressure of 2 atmospheres and a volume of 100 centimeters cubed. Once released airborne, the pressure would drop to 1 atm. What would be the new volume of the gas? All right, well, the first thing you want to do is you want to set up your formula. P1 V1 equals P2 V2. And now what I like to do is I like to set up a chart right here to keep track of all our values. By doing so, it makes it easier for us not to forget things. All right? So our first pressure was 2 atm. Our first volume is 100 centimeters cubed. Wait a minute. You know, we really should change those units. So remember that 1 centimeter cubed is equal to 1 milliliter. What does that mean? Well, if you had 100 centimeters cubed, you would have 100 milliliters. But we don't want the answers in milliliters. Probably, since we're using Boyle's Law, we want to change this to liters. So to change 100 milliliters to liters, we simply go 100 milliliters, set up liters, put the 100 down here, move it 3 spaces over, and you get 0.1 liters. So we put a volume as 0.1 liters. Our second pressure is going to be 1 atm. And our second volume is, we don't know what it is. That's what we're trying to find. So we want to change our formula right here to isolate V2. Right? We want to make that all by itself. So we're going to move P2 under P1 V1. So it's going to look like V2 equals P1 V1 over P2. Pretty simple, huh? So let's just put our values in now. That's what we use this chart for here. Times 0.1 liter divided by ATMs will cancel out, and our volume is going to be 0.2 liters. Well, if you want to know what that was in milliliters and then in centimeters, you just go milliliters. In this case, you're going to move it 3 spaces to the right. 1, 2, 3. So it's going to be 200 milliliters. Since 1 milliliter is equal to 1 centimeter, this would also equal to 1 cubic centimeters. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly. I will see you back here at Moose and Chemistry.